My talk is titled Performance is Sometimes a Mullet, Fast Up Front, but Slow in the Back. I have absolutely no idea what that title is supposed to mean. I didn't write it. It was one of the marketing guys, but it's kind of like clickbait. It got at least you guys to show up, so thanks for coming. So seriously, what am I going to talk about? I'm from a company called Jut. I'll talk a little bit about what we do. A bunch of the talk is going to be about how we built Jut and how Nginx is a critical component of the architecture that we built. And then I'll show off a little bit of how we can mine data from Nginx to get insights into application performance. So like I said, I'm co-founder and VP engineering at Jut. Previously worked at a company called Riverbed, Inktomi and Cray, did a PhD at Berkeley. You may ask what Jut is. We're a startup doing analytics for developers. I'm obliged to say that we are in open beta right now. We'd love it if you'd come try the product. That will be the end of the sales pitch for the day. Mostly. So what Jut is really about is trying to break down silos of information in developer or operations workflows. Traditionally, these different types of data go to different tools, different consoles, forcing people to not only learn different ways of interacting, but they can't bring the data together. And so what we aim to do was really build a data hub where you could bring in all this types of data into one place with really flexible operations that you could do with that. So what does that mean? The types of data we have to ingest range from very unstructured data, like logs, semi-structured data, like maybe Nginx access logs, where there's structure, but you have to parse it for machines to be able to use it, and then very structured metrics, from time series sources, et cetera. We want to be able to process data both live as it's coming in a streaming-oriented way, and then batch to be able to look back historically and look at what's coming in the past. We have this need for a very flexible query processing and visualization layer. And then we have something I think a little bit interesting to talk about, which is the way that we deploy the system is this hybrid SaaS architecture, in which part of our product runs as a traditional web app, and part of it runs securely on-premises for our customers. And I'll talk a little more about how we built that. And for some reason, that build didn't work. But Nginx, like I mentioned before, is both a key component in our ingest pipeline, as well as how we build the SaaS product in the cloud. All right, so let me just start by a little motivating example. I don't know how many people in this room use some sort of chat in their company. I suspect everybody. Chat ops is definitely fairly common. We use Slack. We have started bringing all sorts of data into Slack. And one of the things we sort of found is that when we have problems in operations, oftentimes the root cause is not necessarily the thing being sampled, the metric or whatever, but maybe someone deployed a new version of an app or reconfigured a system component, or an alert went off that a system went down, and that can be the cause of whatever blip you're seeing in your response time, CPU, whatever metric it is that you're looking at. And so you can actually mine this data for some interesting results. So I'm going to just bounce out of PowerPoint for a second and switch over to, this is the Jut app. I'll talk a little more about that later. And this is actually a little something we've called Cursalytics. So why do I say that? The metric you're actually seeing is response time from one of the services in our production infrastructure. This is running live. So those 400 or 500 second response times are things that we might want to take a look at. Nothing fatal, but unexpected. And so what I've done here is I've overlaid events like, this is where somebody upgraded an environment, and that is a message that came from our deployment service into Slack. This is an alert that went off about some host being down. This is somebody in my company saying, holy shit, it worked. And we actually had this theory that when things are going bad, maybe people swear a lot more on Slack. And so every lightning bolt there is sometime that somebody actually swears live on Slack. I'm not joking. If I go over here and say, holy shit, it worked, in a few seconds, that's going to come through the pipeline, and then you'll see a little lightning bolt thing come on the right. There's a little bit of buffering delay. And then my team got a little bit kind of excited about the fact that I was going to show this live at this talk, and I have a couple people of Russian descent. And so they said it would only be fair if we had Russian swear words in there. Does anybody understand what that means here? No? I'm told that that's actually some sort of swearing in Russian, whatever that means. I'm not really sure. But anyway, the point here is not so much that we truly think that swearing on Slack is a good predictor of downtime or anomalies or whatever. You can see there's very little visual correlation. But the point was just that by building a system like ours, you can actually do these things to figure out if there's something kind of interesting or anomalous in your infrastructure. All right, so with that kind of fun little toy out of the way, let's bounce back to, oh wait, I forgot. There's my holy shit, it worked. See, it actually worked. Great. So now kind of going back to a little more of the meat of the actual serious part of the talk. I mentioned before that JUT has a deployment model that's a little bit unusual, and we call this the hybrid SaaS architecture. And so what that means is for people that are using the JUT product, like the demo I just showed, the actual source of kind of what you're looking at comes from really two places. There's the JUT.io cloud, which is a pretty traditional web app. And then there's the data engine component, which is where actually all of the heavy lifting of the data analytics and the ingest and the processing happens. And the important thing to note is that everything kind of inside that gray box is inside the customer's protection domain. So data never leaves their site. Storage is on servers that they control. We never need to look at the data. And what we do instead is, the browser accesses the app from the cloud and then makes cross-domain requests to the engine that's running on-premise, which we manage from kind of a remote management command and control API, sort of like it's periodically checking for updates and applying things that way. And so we found that that really gives the best combination of kind of SaaS-like behavior for the application delivery with really the security and, frankly, cost effectiveness that it comes from allowing people to run the big heavy lifting data engine on their own hardware or virtual hardware. So let me talk a little bit more about how we build these different pieces, and then I'll get into kind of where NGINX fits in. So the cloud, we run a multi-service architecture, using kind of basic DNS to send different requests to different logical services. That's, again, both from the web app and the on-premise components that are polling periodically for updates. We use ELB for basic host load balancing, and then NGINX is the front end of the web tier that handles client process fan-in. It does SSL termination, as does ELB. And then the application logic and our authentication layer happens in a Node.js set of services that are running in the cloud. For this, we found NGINX to be great. None of this is particularly rocket science. I suspect this is kind of like out of the box how you would run a web app these days. But again, NGINX is a pretty critical component there. Where things, I think, get a little more interesting and a little more unusual is when we talk about how we built the bits that run on-premise. And again, this is the JUT data engine that's remotely installed on customer hardware. And let me dive into a little bit of how that actually works and how that's actually put together. So I think I mentioned all this, but it runs on hardware that customers control. They install a simple bootstrap agent to get the software onto the box. And then from that point on, everything is administered remotely. OK, so this is a little bit of a complicated slide. Let me just walk through a little bit of what happens here. So most data that gets into the JUT system, or I should say a lot of it, comes in the form of JSON over HTTP. A lot of data sources that are of interest to us are able to send in that format. Webhooks from Slack, collectd, statsd type metrics. Logstash can output in HTTP for structured logs. Any kind of instrumented app metrics can come in that way. So it's really kind of the preferred way to get data into JUT, send it over HTTP. And for that, NGINX is the gateway. So we will run an embedded copy of NGINX on-premise. It fronts the data. It does SSL termination. It does access key verification. I'll talk about that in a minute. And then forwards on to a node processing layer that does a little bit of transform on the data to get it into the format that we need within the JUT system. Sends it into Kafka for queuing to handle temporary outages and make sure the ingest path is durable. And then it goes to another set of node services that do the actual ingest processing, where we then send it into both Elasticsearch and Cassandra. So we actually use a combination of both of those backends for the different types of data that we have in the JUT system. Elasticsearch is really great for unstructured event type data. It does free text search. It does multifaceted kind of indexing. It can do a bunch of the roll-up analytics on the event data. But we found it to be pretty inefficient for storing really regular time series type data, just because it's not really what it's built for. At the same time, we wanted the capabilities of Elasticsearch to find metrics within our system, and we didn't want to constrain how someone might search for data just because it happened to be a time series. So what we do is we actually use a combination of the two for storing metric data, where we put a metadata record in Elasticsearch so that it's, again, searchable, findable, but the actual regular time series data points, we put those in Cassandra. And that let us get the combination of the query performance and indexing performance that we needed for the regular metric data, while still getting all the flexibility and power of Elasticsearch for searching. And again, one of the important things about both of those is that they're horizontally scalable and do replication, so that even when we're running on hardware that customers control, we can still maintain a cluster of hosts for data durability and scale, and we kind of take care of the orchestration and management of how that cluster gets built. We'll talk a little bit about the security model that we have for getting data into JUT and then making sure that access to these on-premise boxes is secure. It was important to us that we have all communication be protected with SSL. That's, again, not rocket science. But what is a little bit tricky is when you're trying to do SSL on boxes that you don't control, where the IP is not something you can predict ahead of time. So we wanted to make a combination of make it really flexible and easy to deploy, while at the same time still having the security that you get with SSL, which implies that you need a DNS name that would match whatever IP you're talking to the box on. So we went with this model in which every on-premise box gets this dynamically created DNS name that embeds its IP address and the customer identifier, so that then we can deliver a wildcard cert to that box that protects basically any IP address for that customer will be authorized with that cert, which allows us to, again, keep the properties that you get from SSL while still getting a kind of one-click install experience that we'd want for our customers. The last little bit that I thought was kind of clever, in honesty, we only switched to this a couple weeks ago. But for ingest, we authorize the import using an API key per customer that's in the query parameter. This makes it pretty simple to set up a webhook. We don't need any special OAuth headers or things like that. And we originally implemented the authentication in the node layer that was kind of behind Nginx. But one of my engineers realized, well, Nginx can do this perfectly well. So why don't you just leverage Nginx's capability of parsing query parameters? And since we were writing out a templated config for each customer's Nginx kind of on-premise box anyway, it became really trivial in literally this one line of Nginx code to implement our whole kind of ingest authorization stack kind of purely within Nginx. And so that was kind of a great little add and nod to the software, that it was really useful to do that. So I guess kind of in sum, I talked about a couple of the ways that we use Nginx within our system. It's a front end to our REST APIs that are in the cloud. That is managed in a pretty traditional way. We use Chef for the provisioning and management, install it on the system. That's all pretty basic. One thing that I'll show you later is we're able to actually slurp out all the access logs from Nginx and put it into a JUT system for doing kind of the product analytics on how people are using our product. Of course, we can do that because that's kind of in our cloud and in our customer domain, or in our domain. For the on-premise bits, however, it's a little more interesting. Again, it's the front end to the HTTP ingest. It's configured by the JUT remote command and control agent. For us to take access logs from all of our customer boxes, that would be basically prohibitively expensive. Because if you think about it, every time someone posts a chunk of data to the JUT system, if we were to log that and then try to log that into the JUT system, we'd basically double the footprint for the instrumentation. So we have to back off, and we can only do things like use a statsd for aggregated metrics or get things other ways downstream, as well as the kind of core 6 or so metrics that Nginx exports for active connections, waiting connections, kind of those we track, but the actual per request stuff we can't afford to do, so we have to kind of work around that. But we do get rollup metrics and get some information as to what's going on in the Nginx kind of across all of our customers by doing some rollups to the cloud. OK, so that was kind of the first half or so of this talk where I really wanted to kind of go over how we built JUT, what were the main components of kind of how we built the architecture, and then where Nginx fits into the kind of under the covers bits of JUT. Now I'm going to show a little more of the product, but more getting at kind of what you can do with a product like ours, not to actually get really interesting information about what's going on in your system from the sources of data like Nginx logs, as well as kind of these other external events. So for our own deployment of our system, we run an instance of JUT. That seems sort of obvious that we would try to do that. And so we're actually pulling in all these data sources that I'm showing here into our own JUT infrastructure. I kind of showed some of that earlier with the Slack, comparing some of our application metrics. And so let me switch a little bit. And oh, sorry, yeah. So there's another little component that I want to get to. For actually being able to process and query kind of data of these different types, we needed a little bit of a different approach to kind of how we would build a monitoring and analytics platform. So I mentioned before, we need to support both live and historical data. Monitoring, you want to understand what's going on in my system right now. Reporting, I want to look at what's going on in the past. And alerting is usually driven by live, but you want to have some historical data for calibration. And so we basically built a unified processing engine that we call JUTL, in which you express a simple query language to build these data flow graphs that are actually how you process the data, both pulling it out of the data stores and tapping into the data live. And I'll show a little bit about that later, but kind of architecturally, the analytics path is that when I type a command in my browser, that sends a JUTL query in this language over to the node-driven analytics service, which interprets that query and figures out, for answering this request, do I need to tap into the live stream of data? Do I need to pull data out of my historical databases? Or do I want to do both? I'm not sure if you noticed, but when I ran that kind of Cursalytics query earlier, it actually filled in with an hour's worth of data right when I ran it, and then switched over to real time right away. And so that kind of being able to get the context from a historical query, but then decide, when do I make that switch and start tapping into live? Kind of that's what happens in that kind of core analytics service. OK, so let me show another example of where we kind of use this infrastructure to actually solve a kind of understand and solve a real problem in our app. So I'm going to bounce over from the kind of dashboarding view, which is what I showed earlier, over to the view that we call Explorer, where this is where you can actually interact with the JUTL query language and then also see visualizations, whereas the boards is more for kind of real kind of full screen mode. So sorry, this is a little smaller than I'm used to. OK, so if I have a little, here's an example of a little query where we noticed, this is a little while ago, we noticed these periodic spikes in response time in our app. And it sort of seemed to happen once every 5 minutes or so. And this wasn't a service that we had been looking at particularly carefully. Someone noticed this, and we said, oh, we should probably take a look and understand what's going on here. So the first thing we did was, OK, so this was the little JUTL expression that showed me kind of both median and upper 90 percentile response time from a given hostname, sent it to a time chart. Let me do kind of a very similar thing and actually plot, instead of the response times, let me look at a couple of CPU metrics on that same host. And so now I get a couple of different graphs, and you can see, well, it's pretty easy to correlate that the spikes in CPU happen at around the same time as the spikes in the response time, making us feel like, well, it's probably not actually something else. It's just that the server seems overloaded, and it seems to get overloaded for a few seconds every 5 minutes or so. And so we sort of, my team kind of scratched their heads a little bit and tried to see, well, what is it that might be running, every 5 minutes? And it turned out, we were running Chef on those servers once every 5 minutes. And so if I just kind of look at, we're getting all the logs from Chef. And so I can do a little search here and just actually gives me all logs that match the string Chef run complete. And now I see a whole bunch of logs from the various servers that I see in here. And I can kind of scroll through, and I notice that this particular one happens to have taken about a minute. And that's long, right? These other ones are taking kind of 14, 15 seconds at a time, and that seems a little bit anomalous. But we wanted to see, well, kind of how pervasive is that? And so I did a little bit more kind of work with the query language, where I kind of extract the runtime from the message, and then roll it up and kind of grab an average value by host name, and then send that into a bar chart. And so there you can pretty easily see that particular host name, it's kind of anomalous. You can see from the one sample, this rolls it up over all the data that we have in our system. And so we can see, OK, it's pretty clear that this is the same host that's having the CPU problem. And just to kind of pull it all together, if I kind of take this little bit out, not usually coding on the fly, but take this a little bit out. And then instead of taking that, just the Chef runs and plotting them kind of in isolation, what I'm going to do is take those logs where Chef starts and ends, and I'm going to overlay those logs on the two charts that I showed earlier. So I take those back in. And now you can kind of see really clearly that the times when Chef starts to run, it's when things get slow. Times when Chef stops to run, things get better again. The kind of cool thing about this was just, very easy in kind of a couple little turns of it, be able to see like a really clear correlation. This is the problem, and then we can figure out ways to kind of make Chef less of a hog. So the question was, I had to do a bunch of work to find that. Why can't we kind of figure out what all the problems are? So we definitely have a team that's working on kind of some of the automatic anomaly detection. Figuring out that there's a spike here every 5 minutes, that's not that hard. That's pretty straightforward. Correlating that with a log that might have come in from some other area around that time, that's definitely interesting, and it's something we're working on. For right now, the main thing we've been focused on is giving the flexible platform for people to be able to kind of very quickly ask the questions that they care about right now. And then the kind of longer-term goal of the company is definitely to leverage that infrastructure to do more of the kind of automatic detection stuff. So I'm going to switch back to my slides a little bit. One of the things I don't know, maybe this is kind of obvious to people in this room, but one of the things I thought about in this talk was thinking about the kind of wealth of information that's actually available if you just kind of look at access logs from your system and look at the information that's in Nginx, kind of what can you figure out. And it turns out you can actually get to a lot of the answers to these kind of pretty interesting questions really quickly. So if you do basic kind of access log configuration in Nginx, including some metrics like sizes of requests and response time, well then it turns out you can kind of figure out mostly who did an action based on a combination of remote IP, and if you have in our case the account ID is a GUID in the request. What did they do? The operation in RESTful services is typically encoded in the method and the URL, where they came from, a little bit of experience based on response time, and then when it happened. Those are kind of fairly straightforward things by just looking at time. And so I'm going to jump back over to the product again and kind of show another little example where we're able to kind of use this data in kind of interesting ways. So give me a quick second here. All right, so sorry, I had this set up a little bit better earlier. All right, so if I just grab a few access logs, right? I'm sure people here have looked at these kinds of things before. I get the kind of basic metrics about what happened when. I get the path. I get when it happened. I cut out some stuff that wasn't actually relevant to this talk. But in and of itself, these kind of routes and these URLs, they may tell me something. I could take these and I could actually, do various kinds of analytics on them. But what I think is sort of more interesting is if I try to extract some structure from those and figure out, are there any patterns that correspond to a particular action that a bunch of customers are doing or something that a particular customer may be doing. And it turned out all the information you need is actually right in there. So if I kind of go back to a little bit more, I can kind of augment the data points by doing a little on-the-fly transform off the URL where I pull out the kind of nth chunk of the path, which in our case, all of these requests start with the customer ID or the company ID in the kind of fourth element of the path. And then the thing that follows it is, that combined with the HTTP method, that kind of tells you what were they doing in the system. So if I kind of rerun this, well, now every data point, gets augmented with kind of who's the customer and kind of what were they doing. Were they just fetching information about the deployment? Were they getting a list of hosts or doing some sort of access control change? And so then, OK, great. Now I'm able to kind of take that info and then send it to kind of a pretty interesting or sort of basic bar chart here, where I'm actually grabbing response times by not the path anymore, but actually the route. So that's actually not quite right. But what I'm kind of plotting here is kind of by each route, kind of what are the average response times. And I can kind of see, well, these two seem to be slightly slower than the rest. Again, not really telling me very much of interest yet. What we sort of thought would be a little bit more interesting would be to see, like, well, maybe the slow requests aren't actually just by route, but maybe it's actually something correlated with the size of the request. Like maybe it's that the big requests are kind of the slower ones. And so if that were the case, I'd expect to see some sort of like linear correlation on the scatter plot. And I don't really see anything. These seem sort of bundled. But again, looking at these by URL doesn't really tell me very much. Let me just change this little dropdown and then rerun. And now I can actually change the grouping so that I'm starting to see a little bit more patterns. Like, getting the hosts list is kind of always down here. Kind of these modification ones tend to be the slow ones. That might be an area for us to look at for kind of optimization. These couple outliers in terms of the size, that's sort of interesting. I might want to follow up with that. What I think was sort of, important for us was, this is useful as kind of a point-in-time snapshot of what, happened on my server, within the last 10 minutes. But you might actually want to also change this so that it shows you, with a little change, kind of what's happening on the server right now. And so if I make that change, now I'm actually taking the data in real time. And then basically every request that comes into our site gets analyzed, processed, put onto this chart. And so I can actually see kind of patterns in the data through the kind of animations as things are kind of going on live. So you kind of see when slow requests come in, you'll get some outliers that come up on the top. You sort of end up seeing the clustering as different, different behaviors are happening. And so, this is the kind of thing where you might want to have this kind of dynamic kind of display as, a piece of your wallboard where you're sort of seeing, are there anything strange that, I might be able to visually see as a human some sort of correlations that are, kind of hard for, harder for machines to look at. And again, the kind of interesting thing, just kind of bringing it back to why I think a lot of you are here, is kind of all this data is just mined from the Nginx access logs in our kind of basic SaaS service fronting a REST API. There isn't really anything that we had to do other than just pulling it into a system that was able to kind of do the kind of transformations that we can do, extract information, and do the visualizations. So that's kind of all I have for the talk. We have a few minutes more for questions. Thanks very much.